The following is the video solution from JSDT Solutions. Question 1 says we have a quadrilateral. So A, B, C, D is a quadrilateral on the Cartesian plane with vertices A, B, C, and D. And we can see that the x value is missing there. And the first question is to determine the gradient of AC. Okay, they've given you A, they've given you C, so you can find the gradient. So we use the gradient formula, which is y2 minus y1 over x2 minus x1. So the gradient of AC is equal to, just follow one order, okay? Top minus bottom or bottom minus top, it's fine. I'm just going to go with top minus bottom. So I'll say we're going to just go for 1 minus negative 3 all over, and this is negative 3 minus 5. And then you just simplify your gradient. So the gradient of AC, that will give us 4 on top, and that gives us negative 8. So 4 over negative 8 is negative a half, and that is our answer. Moving on to the next question. And then 1.2 says calculate the equation of AC. Great, we have the gradient of AC. You just need to use 1 point on that line AC to find the equation. So I'll go ahead and use A, negative 3 and 1. So if this is negative 3 and 1, you can use y equals mx plus c, or you can use this formula, y minus y1 is equal to your gradient, which is negative 1 over 2 times x minus x1. And then we'll just substitute. So x1 and y1 are your points, okay, the coordinates of your points. So that's x1, that's y1, and so that is y minus 1 is equal to negative a half, and then x minus negative 3. So minus negative 3 just becomes plus 3. And now we can just simplify this. So start with the right hand side because you're just going to transpose that. So this is negative a half x, and that becomes negative 3 over 2. Then when we transpose, it becomes plus 1, and this is y is equal to. So y is finally equal to negative a half x. So 1 minus, you can see that this is bigger and it's negative. So it will be negative a half. And that is our answer. That is the equation of AC. Moving on to the next question. Question 1.3 says, calculate the angle of inclination of AC. So angle of inclination. So just that angle that it creates with the x-axis. So here's the x-axis, here's AC. We're just trying to find that angle. And the reason I'm doing this is because I'm just checking. This is an obtuse angle. Okay, the gradient was negative, meaning this line is a decreasing function, and we need to just remember what to do with that. So to find the angle of inclination, we say tan theta is equal to our gradient. So tan theta equals gradient, and our gradient of AC was negative a half. Okay, so this is negative a half. So find theta. Naturally, we would just transpose, okay, to make that the second function of tan. But just remember what happens when you do this, because you have a negative value. The minute you say shift tan negative 1 over 2, you get a negative number. Okay, and we don't want to just use that because what you're measuring here is not this obtuse angle. You are measuring this little angle, okay? Or you could even look at it as you're measuring from this part over here. Okay, so we don't want to do that. And so that we can get the positive angle, what we do is we add 180 degrees to this. Okay, so if you measure this angle and you wanted to get this obtuse angle, you're adding 180 degrees from this point. 180 degrees creates a perfect straight line. 180 degrees will cause this to go from this point, okay, and then reach here. But remember, this was negative, so it doesn't even have a value for those parts. It gets to here, reaches 0, and then calculates the value of the obtuse angle. So that's what we're doing. So we're just going to say plus 180 degrees, and that gives us 153 degrees. So you need to include that here, plus 180 degrees. So theta is finally equal to 153.43 degrees, and that is our answer. Moving on to the next question. Question 1.4 says, determine the coordinates of D if AC is the perpendicular bisector of DB. Okay, so let's see what this looks like. They said that AC is the perpendicular bisector. Okay, so if it is a bisector, it means that this line AC cuts BD into two equal parts, meaning BM is now equal to MD. But it's specifically a perpendicular bisector, and that means that when it cuts it into two equal parts, it's also perpendicular to BD. Okay, so AC is perpendicular to BD, and it also cuts it into two equal parts. So how can we use this information to find D, the coordinates of D? So find X really. Now see that you can't really use the midpoint formula. It's not helpful here because we don't even know what M is. So we can't really do that. Let's skip that. And we can just use the fact that these lines are perpendicular. We have the gradient of AC. It's negative a half. We can try to find the gradient of BD. And because we know that perpendicular lines have gradients that do this, the product of their gradients, if you say the gradients of one line multiplied by the other line, they give you -1. And then we can use that to solve for X because everything else will be complete in the gradient formulas that we'll have except for X. That's the only thing that will be missing. Okay, so let's go ahead and do that. So we already know the gradient of AC. That is negative a half. And now let's find the gradient of BD. So gradient of BD, we're going to say y2 minus y1. So you can just follow, well, I want X to be first. So let's follow 0 minus -4. So 0 minus -4 over, and then x2 minus x1, that's x minus 2. And so this is 4 over x minus 2. Now, because these lines are perpendicular, it means that the gradient of, so we can state that, because we know that AC is perpendicular to BD, then this means that the gradient of AC multiplied by the gradient of BD, that is equal to -1. So the gradient of AC is -1 over 2, so -1 over 2, multiplied by the gradient of BD, which is 4 over x minus 2, and that is equal to -1. And we just have to solve for X in this equation. Okay, so to solve for X quickly, you can just decide to divide both hand sides by -1 over 2, but I will choose to just multiply both hand sides by -2 over 1, which is just -2. Okay, and that will cancel that. So times -2 over 1 as well, which is -2. And then this gives us positive, they cancel, and we still have 4 over x minus 2, and this gives us +2. And at this point, you can just cross multiply. So this will multiply with a 2 to give us 2 times x, which is 2x, and 2 times -2, which is -4, which is equal to, this has a natural denominator of 1, so 4 and 1 multiply to give you 4. This will go over and become +4, so that is 2x equals 8. Divide both hand sides by 2, and x is therefore equal to 4. And that is our answer. So it means that D, that x-intercept, is simply 4 and 0. And that is our answer. Moving on to the next question. Question 1.5 says, hence, deduce that ABCD is a kite. So prove that this, or really just conclude that this shape is a kite. So it's still proving really. How do you conclude or show that this shape is a kite? How do you prove that a shape is a kite? Well, a kite is actually one of the simplest ones to prove because there's just one way. To prove that a shape is a kite, you can prove that, I don't know why I'm throwing it out, the shape is already there. But to prove that a shape is a kite, if you can show them that this side is equal to this side, the adjacent sides are equal, so these two are equal and these two are equal, then it's a kite. And that's what we're going to focus on. So all we're doing is finding the lengths, given that, you know, we have all the sides. Yeah, that's probably why they asked us to find D. Okay, so we know everything that is here now. We're just going to find these lengths. Okay, so the first set of sides we need to find would be AB and AD. So let's find the distance of AB. So it's just using the distance formula. I'm going to just put the distance formula down already. So square root of x2 minus x1 all squared plus y2 minus y1 all squared. And now we're just finding all these distances. So AB is equal to the square root of, and we're saying, you can go in any order, top minus bottom is fine because you're still squaring it at the end of the day. So -3 minus 2 all squared plus, and then the y's are 1 minus negative 4, which becomes a plus 4, all squared, and we'll find AB, okay? Okay, and that is 5 square root 5. And let's go ahead and find AD. So AD, and we're just going to use the same formula again. So x2 minus x1, AD, that's going to be, we know this now, the x value is 4. So just keep that in mind, that is 4. And so negative 3 minus 4 all squared plus, and we have 1 minus 0 all squared. Okay, so like that. And let's just substitute. And that's also 5 square root 2. Okay, I noticed I said square root 5, square root 2. Okay, 5 square root 2. So this is also equal to 5 square root 2. So 5 root 2. And so these two are equal. Now let's just get the other pair. So we also need to find BC and CD. It's just finding the distance. So BC is equal to, and then we'll substitute. And that is equal to the square root of 10. So root 10. And then we can find CD. So CD is equal to, which is also equal to the square root of 10. Okay, so here's the thing. You see that AB is equal to AD. And BC is equal to CD. So since we have that, okay, we see that this is equal to this and this is equal to this, then this is a kite. So we can finally conclude that this is a kite. ABCD is a kite because we have each pair, or we can just say 2 pairs of adjacent sides equal. Okay, and that is our answer. Moving on to the next question. Question 1.6 says, calculate the area of triangle ABD. Okay, so triangle ABD, this triangle over here, how can we find that area? Okay, always try to go with a half base times height first before looking into other things, because it's just one of the simplest ways to work with this. So to find the area of this triangle, and let me just get it down there. Okay, so we have the base. We can use BD as the base, and we're just going to find the distance. Okay, we can find the distance of that base, and then we'll have to find this midpoint, because you see that these lines are perpendicular, so this can serve as the height. Okay, so things we need to find. We need to find BD, we need to find the midpoint, and then AM. Okay, let's go. So find BD. To find BD, this is equal to, and we'll just use the distance formula. Remember that this is 4, so I can just say top minus bottom with the x and y value. So that is 4 minus 2 all squared plus 0 minus negative 4, which becomes plus 4 all squared. And let's just get the length of BD first. And that is 2 square root 5. And now we can find the midpoint. So we need to find M, so we can find AM. So to find M, just use the midpoint formula. And so that is x1 plus x2. So I'll take that as 4. So 4 plus 2 over 2. And then y1 plus y2, which is 0, plus negative 4, which just becomes minus 4 over 2. And so the midpoint is simply, that's going to be 6 over 2, which is 3. And then negative 4 over 2, which is negative 2. Okay, half base times height is always going to give you the most accurate answer. Okay, if you use the sign, the area rule, you will get to the right answer, but you'll notice there will be decimal points that you round up to, and then you finally get the answer that you would have gotten with this method. Okay, so we found BD, we found M, and now we need to find AM. Okay, so AM, we know what A is and M. So use the distance formula. AM is equal to, and we're just saying top minus bottom. Okay, I'm just making sure that A is fine. So this is x2 minus x1, which is negative 3 minus 3 all squared, plus 1 minus negative 2, which becomes plus 2 all squared. And let's find the length of AM. And that is 3 square root 5. Okay, so here, to find the area of this triangle, ABD, so that's ABD, we simply say a half multiplied by the base, and that was BD, and we know that is 2 square root 5, and then multiply by the height, which is AM, 3 square root 5. So this is equal to, this is just going to be a half, and then 2 times 3 is 6, and then root 5 times root 5 is 5, that's 30 30 divided by 2 is 15. So this is 15 square units, and we can just say units squared, and that is our answer. Okay, 15 square units. And that is it for question 1.